Good morning. Today we have to take one more topic, that is 14th topic, dual nature of radiation and matter. Dual nature of radiation and matter एकदम लहान टॉपिक आहे. Dual nature of radiation matter. In this topic we have to see photoelectric effect. Photoelectric effect. In this topic we have to study about photoelectric effects, its characteristics, experimental study, as well as uses. Now see, in 1887 Hertz, HEARTS, Hertz discovered the phenomenon of photoelectric effect. Suppose this one as any type of matter. Suppose this one as any type of metal pharmana which contains large number of negatively charged free electrons. Any type of metal contains large number of free electrons. All these electrons are always in the state of random motion within metal only, but they cannot escape from metal because they have not sufficient energy. When radiations of suitable frequency incident on this metal plate, incident radiations contains photons. Incident radiations contains photons having energy h mu. H Planck constant, mu frequency of radiations. Incident radiations contains photons. When radiations incident on metal, then these photons collide on electrons and transfer their energy to that of electrons. When radiant energy incident on this metal plate, then these photons collide on electrons and transfer their energy to that of electrons. Energy of electrons increases due to which they are emitted from metal. म्हणजेच हे फोटॉन्स इलेक्ट्रॉनला एनर्जी सप्लाय करतात. इलेक्ट्रॉनची एनर्जी इन्क्रीज होते आणि मग ते या मेटल मधून बाहेर पडतात. बाहेर पडणारे जे इलेक्ट्रॉन्स आहेत, द इलेक्ट्रॉन्स इमिटेड ड्यू टू दिस इफेक्ट आर कॉल्ड एज फोटो electrons, and current due to that photoelectron is called as photoelectric current. This effect is called as photoelectric effect. What is that photoelectric effect? The phenomenon of emission of electrons from metal. The phenomenon of emission of electrons from metal. The phenomenon of emission of electrons from metal when exposed in a light of suitable frequency. Incident radiations must have some minimum suitable frequency. This phenomena is called as photoelectric effect. What is photoelectric effect? The phenomenon of emission of electrons from metal when exposed in a light of suitable frequency is called as photoelectrons. The electrons emitted in this process are called as photoelectrons, and current due to that photoelectrons is called as photoelectric current. The metals like झिंक, त्यानंतर कॅडमियम, मॅग्नेशियम etc. Ultraviolet radiation is necessary. Ultraviolet light is necessary for emission of photoelectrons. For alkali metals, even if visible radiations are sufficient for emission of photoelectrons. Okay. Now, experimental study of photoelectric effect. Experimental study of photoelectric effect. Photoelectric effect. Experimental study of photoelectric effect. See. Experimental arrangement. Experimental arrangement consists of an evacuated glass tube. Experimental arrangement consists of an evacuated glass tube or glass bulb like this. Evacuated glass tube G having a side tube provided with quartz window. Here quartz window. Two metal plates that are photosensitive emitter plate. Two metal plates that are photosensitive emitter plate and collector plates are fixed at the ends of tube, acts as two electrodes. This is emitter plate, this one as collector plate, side tube provided with quartz window, QUARTZ window. Now see, like this. These are acts as two electrodes. Now या ठिकाणी आपण एक कॉम्युटेटर की वापरतोय. या ठिकाणी आपण एक कॉम्युटेटर की वापरतोय. ह्याला म्हणतात कॉम्युटेटर की. त्याला म्हणतात कॉम्युटेटर की like this. इथं ही कॉम्युटेटर की. इथं व्हेरिएबल रेजिस्टन्स और रिओस्टॅट. इथे कसं आपण व्हेरिएबल रेजिस्टन्स और रिओस्टॅट वापरतोय. high tension battery. ह्याला म्हणतात कॉम्युटेटर की. कॉम्युटेटर की ही तर पोटेन्शियल डिवायडर अरेंजमेंट हा भाग. पोटेन्शियल डिवायडर अरेंजमेंट हे झालं एक्सपेरिमेंटल सेटअप ऑफ फोटोइलेक्ट्रिक इफेक्ट. सी एक्सपेरिमेंटल स्टडी ऑफ फोटोइलेक्ट्रिक इफेक्ट. First, it consists of an evacuated glass tube G having a side tube provided with quartz window. Second, it has two metal plates that are photosensitive emitter plate and collector plate fitted at two ends acts as two electrodes. Third one, by means of commutator key, collector can be made positive or negative with respect to emitter. This is commutator key. By using commutator key, collector C can be made positive or negative with respect to emitter. By using potential divider arrangement, potential given between emitter and collector can be changed. Fifth one, microammeter is used to measure photoelectric current. This is about experimental setup. आता experimental observations. Experimental observations. पहिला, variation of frequency of incident radiation at constant intensity of incident radiations and potential given between emitter and collector. कोणाचं व्हेरिएशन पाहतोय आपण? फ्रिक्वेन्सीचं. कॉन्स्टंट काय ठेवलं? इंटेन्सिटी ऑफ इन्सिडेंट रेडिएशन. इंटेन्सिटी ऑफ इन्सिडेंट रेडिएशन अँड पोटेन्शियल बिटवीन, म्हणजे या ठिकाणी अप्लाय केलेलं पोटेन्शियल कॉन्स्टंट आहे आणि इंटेन्सिटी पण कॉन्स्टंट आहे. जर समजा आपण रॅडियंट एनर्जी इन्सिडेंट केली, radiant energy contains photons. These photons collide on metal due to which electrons are emitted. Suppose these are emitted electrons like this. These are emitted electrons called as photoelectrons like this. पहिलं समजा आपण याची फ्रिक्वेन्सी चेंज करत गेलो. Variation of frequency at constant intensity of incident radiations and potential between emitter and collector. If the graph of photoelectric current with frequency of incident radiation is plotted, the nature of graph is like this. तर त्याचा ग्राफ हा असा तयार होत असतो. बघा इथं फ्रिक्वेन्सी ऑफ इन्सिडेंट रेडिएशन्स, फोटो इलेक्ट्रिक करंट IP like this. Variation of frequency of incident radiation at constant intensity of incident radiation and potential between emitter and collector. It is found that for small frequency of incident radiations, photoelectrons does not emitted or photoelectric effect is not possible. Second, the minimum frequency of incident radiations must be required. The minimum frequency of incident radiations must be required for emission of photoelectrons. This frequency is called as threshold frequency, THESHOLD. Threshold frequency. What is threshold frequency? The minimum frequency of incident radiations. The minimum frequency of incident radiations for which photoelectrons just emitted is called as threshold frequency. Above this threshold frequency, photoelectric current IP is directly proportional to frequency. And one more point, this threshold frequency is different for different metals. म्हणजे जर समजा आपण इमिटर प्लेटचं मेटल जर समजा चेंज केलं, या ठिकाणचे मेटल प्लेट आपण चेंज केली तर त्याची थ्रेशोल्ड फ्रिक्वेन्सी ही पण चेंज होत असते. पहिलं ऑब्झर्वेशन अबाउट फ्रिक्वेन्सी, variation of frequency at constant intensity of incident radiations and potential between emitter and collector. If the graph of photoelectric current with frequency is plotted, then nature of graph is like this. आता यावरून एक दोन तीन ऑब्झर्वेशन्स आपण तयार करतोय. पहिलं, फॉर स्मॉल फ्रिक्वेन्सी ऑफ इन्सिडेंट रेडिएशन्स photoelectric effect is not possible. Means photoelectrons does not emitted from metal. Second, minimum frequency must be required, called as threshold frequency, for emission of photoelectrons. What is threshold frequency? The minimum frequency of incident radiations must be required for emission of photoelectrons is called as threshold frequency. Fourth, above this threshold frequency, photoelectric current is directly proportional to frequency of incident radiations. And one more, this threshold frequency is different for different metals. हे जर आपलं पहिलं ऑब्झर्वेशन. ओके, आता आपण पाहतोय सेकंड ऑब्झर्वेशन. सेकंड ऑब्झर्वेशन, that is variation of intensity of incident radiation at constant frequency greater than threshold frequency and potential between emitter and collector. कोणाचं व्हेरिएशन पाहतोय आपण? इंटेन्सिटी. कॉन्स्टंट काय ठेवलं? फ्रिक्वेन्सी ऑफ इन्सिडेंट रेडिएशन, बट दॅट कॉन्स्टंट फ्रिक्वेन्सी मस्ट बी ग्रेटर दॅन थ्रेशोल्ड फ्रिक्वेन्सी and potential between emitter and collector. Experimentally it is found that here graph of intensity of incident radiation with photoelectric current IP. Intensity. Experimentally it is found that photoelectric current is directly proportional to intensity of incident radiations. Photoelectric current is directly proportional to intensity of incident radiations. That is, photoelectric current flows even at low intensity. Means rate of emission of photoelectrons, rate of emission of photoelectrons is directly proportional to intensity of incident radiations. Second observation, variation of intensity at constant frequency greater than threshold frequency and potential. Experimentally it is found that even at low intensity of incident radiations, photoelectric effect is possible. Means photoelectrons are emitted, and this rate of emission of photoelectrons is directly proportional to intensity of incident radiations. त्यानंतर थर्ड, variation of positive potential given to collector at constant frequency greater than threshold frequency and intensity of incident radiations. आता इथं काय करतोय, फ्रिक्वेन्सी आणि इंटेन्सिटी कॉन्स्टंट आहे. व्हेरिएशन पॉझिटिव्ह पोटेन्शियल गिव्हन टू कलेक्टर, कलेक्टरचं पॉझिटिव्ह पोटेन्शियल. आता बघा या ठिकाणी या कॉम्युटेटर कीच्या सायन्स समजा हे पॉझिटिव्ह असेल तर हे पॉझिटिव्ह आपल्याला डायरेक्ट हे टर्मिनल इथं कनेक्ट करून पॉझिटिव्ह पोटेन्शियल देता येतं. याच्या साह्याने हे बदललं तर निगेटिव्ह टर्मिनल पण देता येतं. आपण काय करतो, याचं पॉझिटिव्ह पोटेन्शियल इन्क्रीज करतोय. व्हेरिएशन ऑफ पॉझिटिव्ह पोटेन्शियल गिव्हन टू कलेक्टर ॲट कॉन्स्टंट फ्रिक्वेन्सी greater than threshold frequency and intensity of incident radiations. See, if the graph of photoelectric current with positive potential given to collector is plotted, then photoelectric current IP पॉझिटिव्ह पोटेन्शियल या बाजूला निगेटिव्ह पोटेन्शियल इथं ओरिजिन. व्हेरिएशन ऑफ पॉझिटिव्ह पोटेन्शियल द ग्राफ इज लाईक दिस. तर त्याचा ग्राफ हा आपला असा मिळतो. At constant frequency and incident radiations, as positive potential given to collector increases, photoelectric current increases and reaches to its maximum value. After that, even if positive potential increases, photoelectric current remains constant. That maximum constant photoelectric current is called as saturation current. Saturation current. What is saturation current? That is maximum constant. Experimentally found that as positive potential given to collector increases, then initially photoelectric current increases and reaches to its maximum value and remains constant. That maximum current is called as saturation current, and this saturation current depends upon intensity of incident radiation but not frequency of incident radiation. The saturation current increases with intensity of incident radiations. Fourth one, याच पद्धतीनं व्हेरिएशन of negative potential given to collector at constant frequency of incident radiation which is greater than threshold frequency and intensity. Experimentally it is found that as negative potential given to collector increases, then photoelectric current decreases at a particular negative potential. At a particular negative potential given to collector, photoelectric current is 0. Means this negative potential is sufficient to stop the maximum kinetic energy of electrons. Therefore, this potential is called as stopping potential. Stopping potential. This negative potential is sufficient to stop the maximum kinetic energy of electrons, called as stopping potential. As this potential is just sufficient to stop the maximum kinetic energy of electrons, the maximum kinetic energy of electrons is equal to stopping potential Pho into charge on electron. Maximum kinetic energy of electron, that is stopping potential into charge on that electrons. Now one more, that is fifth observation, instantaneous process. Instantaneous process. As soon as photoelectrons, as soon as radiations incident on metal, photoelectrons are emitted within no time. There is no time lag. There is no time lag between the incident of light and emission of photoelectrons, and that time lag is about nearly 10 raised to minus 9 seconds. As soon as incident radiation stopped, photoelectric current is also stopped. Means as soon as radiant energy incident on metal, photoelectrons are emitted within time lag pramana, and as incident radiation stopped, photoelectric current is also stopped. This photoelectric effect is an instantaneous process. These are some observations. Variation of frequency, variation of intensity, variation of positive potential given to collector, and variation of negative potential given to collector, and instantaneous process. These are some observations. आता खरं तर याची फेल्युअर पण आहेत पहा. फेल्युअर्स, FAILUR, failure of wave theory. Failure of wave theory to explain photoelectric effect. Wave theoryचं failure काय नेमकं? This theory could not explain photoelectric effect. Why? पहिलं, instantaneous effect. Instantaneous effect. According to wave theory of light, when radiations incident on metal surface, then it will take some time. According to wave theory of light, when radiations are incident on metal, then it will take some time to accumulate sufficient energy and knock out electrons. Greater the intensity of incident radiation, more will be energy transfer, and hence less time must be required for emission of photoelectrons. Also, smaller the intensity of incident radiation, smaller will be incident energy, and hence larger will be time required for emission of photoelectrons. But photoelectric effect is an instantaneous process. According to wave theory, some time when light incident on metal surface, then it will take some time to accumulate sufficient energy and emission of photoelectrons. If intensity of incident radiation is more, then more energy is transferred and less time must be required. If intensity of incident radiation is smaller, then smaller will be the energy transfer and more will be time required. But photoelectric effect is instantaneous process. त्यानंतर energy of ejected electrons. Second one, that is energy of ejected electrons. According to wave theory, If intensity of incident radiation is large, then more will be energy transferred and photoelectron will be emitted with maximum kinetic energy. विवेक थेरम काय सांगितलं? Intensity of incident radiations. If intensity of incident radiations is more or large, more will be energy transfer and photoelectrons will be emitted with maximum kinetic energy. Thus, maximum kinetic energy of ejected electron depends upon intensity of incident radiations, but experimentally it is found that the maximum kinetic energy of ejected electron depends only upon frequency of incident radiations. The maximum experimentally it is found that maximum kinetic energy of ejected electrons depends upon frequency of incident radiations but not intensity of radiations. Means minimum threshold frequency is required for emission of photoelectrons. Minimum threshold frequency is necessary for emission of photoelectrons. म्हणजे दोन फॅल्युअर आहेत, एक म्हणजेच इन्स्टंटेनियस इफेक्ट आणि एनर्जी ऑफ इजेक्टेड इलेक्ट्रॉन्स. अकॉर्डिंग टू वेव्ह थिअरी, इफ किंवा मॅक्सिमम कायनेटिक एनर्जी ऑफ इजेक्टेड इलेक्ट्रॉन डिपेंड्स अपॉन इंटेन्सिटी, but experimentally it is found that maximum kinetic energy of ejected electron depends upon frequency of incident radiations but not intensity. हे दोन याचे फेल्युअर आहेत. ओके, नेक्स्ट पार्ट ऑन नेक्स्ट पीरियड.